I'm just doing the programming sequence for 501 Electronics Kit Project 474, illumination with speed control. Kind of get your Knight Rider light effect. So powered the computer on, and there's game mode, program debugging and running, cyclocross pick program, gives you the first line number automatically. It's all pretty simple press, so move, press enter to B, enter, value of 20, press enter, line 1, here we go, move, C, 00, line 2, jump, to line 5, line 3 is a move from B, or to B, right, move, B, 27, line 4, move, C, value 01, line 5, move, it's got a 3 function feature, so we want it so we have move the register numbers, this is an at symbol here, we want to move A at B, it says, correct. Line 6, we are going to output the value in A. So whatever's in register A will be outputted here. And this will be one of the lighting patterns that we're going to program in. And at the start of the sequence it might be this light here, L1. Next part of the sequence it'll be L2. L1 will be off, L2, then L3. Blink across and then come back again. This is what we're going to do now. So line 7 is a time, TMP, timing 1. And this will be for 30 milliseconds. That's a hex value. Line 8, standard move, register A, 00, 9, let's output A again. Oh, sorry, output was 9 is output A. 90A is get input from D. So input D. I think that refers to this input here. 90B and operation. And D and the value 01. 90C jump 0, and that is going to be to OA. 90D inputting from D again. OE is an AND operation. OE and the D register, value 01. OF, jump not 0. Value OD. And 10, compare, CMP. Where's that gone now? Compare. C01. 11, jump 0. 18, It's not too bad to program this. Let's get used to it. Line 12. Clear the carry flag. CLC. Help me out here. Let's double press CLC and line 12. Yep, it should be line 13. Increment B. Increment B. Line. Oh, let's skip the adverts on YouTube. Music's playing in the background. So line 14. Move A value 27. Line 15. We're halfway through now. Comparing A to B. Comparing A. Oh, do I have to go back? Cause A to B. I think the compare has some modes. There we go. So line 15, comparing A to B. You can see the modes changing there. So this one, comparing A to B. Line 16. If the end of the table, we're going to jump condition here, JC. And that value is 0.3. Line 17. Jumping to line 5. Jump to line 5. 18. Clear the carry flag. Where did that go again? There you go. 19. Let's decrement B again. Deck B. 1A. Moving A. Moving A, value 20. Line 16. Oh, sorry, it's 1B. It's a comparing B to A this time. So where did we have comparing two registers B to A. Line 1C, jump into line 0, 0. JC 0, 0. 1D, jumping to line 5. JMP to line 5. 1E is a no-op. Where did that go again? Nop. Pingu. Nop. 1F is another nop. Okay. Now line 20, we need entering hex values. This is the part of the program where you're entering in the lighting pattern that you're going to produce. It's literally going up hex 02, 22 is hex 04, oh sorry, hex 04, 123, 08, hex 08, 24, hex 10, 25, hex 20, 26, hex 40, finally line 27, hex 80. That's the last of the program entered. There's no line 28. So at this point now we can go back and run the program, and I'm going to switch on the circuit down here. That wiring has activated this lot. I'll go over here, that's the photo transistor. So we need to escape back out and switch over to run and press enter. And again, I believe I press the run button. Is it running? I can't see any lights. I wonder if we have an issue going on. This is the first time I've ever. It's supposed to be when you do this that the lights will come on. I guess I've got something wrong here. Like switching it on would help. There you go. Each time it's receiving a signal, we're changing the photo transistor. There you go. So we can move this control as well. So I'll put this fully over to the left. What happens now? Each time there's a pulse coming in from the photo transistor, it's changing the sequence. Let's take this light out. Let's put the control hard over the other way. Let's do it slowly now. It's doing it by itself. Okay, well that's a start. Success first time. Now to make it faster, if you remember, we went back into the program. There was a value. Let's stop that now and escape. Let's go back to program. Press enter. We'll just go down there. You remember there was a time entry here where it waited for 30 milliseconds before it made a change. So what if we make that value different? So what happens if you made that a 1, for example? Press enter. Okay, everything's there. Press escape. Scroll across. Press run. 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 Go. Does it need to change to set it off or something? Go on then, run. Oh, what's happened now? There you go. Something happened. Is it just going step? Seems to stop. Let's try again. Double press enter now. That says run. I think it was that value that I put in has knocked it up. Quite possibly. Let's try. Oh, let's start to go back. There's time. Okay, what was it? 3. Center. Escape. Run. Yeah, it was that value I put in, wasn't it? Yeah, it's running again. Obviously need to push up on my hex values for what time it is. Right. Oh yeah, it's waiting for a change, isn't it? There you go. Yeah, so we can see the photo transistor is the governing factor there. It seems to have started doing its own thing there, because I'm waving my hand about, causing a change. There we go, it's running by itself. Yeah, I need to change the timing to make that go faster. Yeah, in the circuit there's all these capacitors here being put in, so it gives you a bit of a fade out effect. It isn't too bad. If you wanted more of a fade out effect, you could up the values. These are 10 microfarad capacitors in an arrangement. This would be the charging capacitor, and that's the charging resistor. And the biasing for the transistors are here. Of course, when there's no signal from the processor, it's the capacitor that's keeping the base switched on for as best it can, and the last bit of energy just to make the LED fade out. Without it, the LEDs would be sharp on and off. Well, that's about it, and there's a couple of little glitches there, but it was a successful project. Been fun doing it. Thanks for watching.